Hello everyone. In this video, I will be discussing the priority scheduling algorithm, which is one of the important CPU scheduling techniques used in operating systems. This algorithm allows the CPU to decide which process to execute based on priority, instead of just arrival time. By the end of this video, you will understand how it works, see an example, and learn its advantage and disadvantage. What is priority scheduling? Priority scheduling is a CPU scheduling algorithm where each process is assigned a priority value. The CPU always selects the process with the highest priority to execute first. Usually, a lower number means higher priority. This method is very useful in systems where some tasks are more important than others. Priority scheduling can be classified into two types. First is non-preemptive priority scheduling. Here, once a process starts executing, it continues until it finishes, even if a higher priority process arrives. The second is preemptive priority scheduling. In this case, if a higher priority process enters the ready queue, it can interrupt the currently running process. Here is how priority scheduling works step by step. First, each process is assigned a priority. Next, process enter the ready queue. The CPU then selects the process with the highest priority. If two processes have the same priority, first come, first served is used. This process continues until all processes are completed. Let us define some important terms. Arrival time is when a process enters the ready queue. Burst time is the total CPU time needed by the process. Priority indicates how important the process is. Waiting time is how long a process waits before execution. Turnaround time is the total time from arrival until completion. Let's look at an example using non-preemptive priority scheduling. We have four processes. We have P1, P2, and P4. Each process has an arrival time, burst time, and priority. Since a lower number means higher priority, P2 has the highest priority followed by P4, P1, and P3. Now the execution order becomes P1, then P2, then P4, and then finally P3. This order is shown in the Gantt chart, which help us visualize how the CPU executes its process over time. Using the Gantt chart, we calculate the average waiting time, which is 7.75 units, and the average turnaround time, which is 14.25 units. Now let us discuss the advantages of priority scheduling. Priority scheduling ensures the important tasks are executed first. It is very useful in real-time systems. It also supports both preemptive and non-preemptive execution. And the disadvantages is low priority processes may suffer from starvation, meaning they may never get CPU time. Also, assigning priorities correctly can be difficult. In conclusion, priority scheduling is a powerful algorithm that focuses on importance rather than arrival time. Compared to first come first serve, it is more flexible and efficient for critical tasks, but it must be managed carefully to avoid starvation.